we do some reverse engineering, and lately we design cool new open source projects and products for musicians. We have been redesigning a control board for a Strymon Deco. More generally, all of the Strymon small box pedals that might not have MIDI, so that your older Strymons can be brought up to date, along with the re-releases. This is not officially endorsed by Strymon in any way. Can be brought up to date. Again, what have we got? Kind of MIDI in and out. We're also going to be adding Bluetooth to it. And a whole bunch of other really cool features, some RGB LEDs for both the indicator LEDs, the option for backlit potentiometers, all sorts of really cool stuff. So we will probably just crack straight into it. Let me open up the project file. If you're just tuning in, welcome. We use Fusion 360 for this project and for all of our open source projects because it is freely available. There's a DIY license, like a hobbyist license. There are some restrictions and limitations, but for designing a PCB, integrating it into a 3D model, like we've done here, it's absolutely perfect for this kind of thing. And yeah, the PCB editor, the ECAD side of things, does have its quirks, definitely. Every ECAD is going to have its quirks. It's really just a matter of what tool can get the job done. There's a lot of fanboyism between KiCad, sort of Eagle now, Fusion, and then Altium's sort of its own thing because it's a higher grade, more professional industry tool. DipTrace, another popular one, and there's a lot of fanboys for either camp. If you're just diving in, you kind of can't go wrong in a sense, and it really just comes down to what you want to do. If you just want to be designing PCBs, then I'd probably recommend getting started with KiCad. It's going to be, it's an open source project, has a really good open source community. And if you just want to get straight into it, then it's probably going to be the best option. So, excuse me. There's a remnants of a cold, not COVID, but just that lingering cough that doesn't seem to go away. But I'd probably recommend doing that. If you come from any sort of Eagle background, then I'd recommend Fusion, I think, because it's all about what tool can get the job done with the least friction. So just keep that in mind. It's not about which one's, the be-all and end-all god tier of PCB tools. It's about what allows you to get what it is that you want done, be it work or, fun, a project. What allows you to get it done with the least friction in the shortest amount of time to get a good quality product. So this is our 2D PCB layout here. Now we haven't actually pushed this to 3D yet. So we finished off this kind of, fairly cemented in, we might tweak and change a few things as we're routing, but a fairly finalized PCB layout, and it's looking pretty good. We've been talking about some design rules, like some best practices and things like that. So I definitely give last week's stream a follow along if you are just starting into PCB layout and design and want to learn a bit more. So here's our 3D model. So we've got our DAC circuitry here. So these op amps, level shifters, everything else in there is a fairly specialized circuit tuned to this application so that we get full rail-to-rail performance out of our PWM outputs from the RP2040, which is here. We've got some decoupling capacitors, our crystal here for timing, LEDs and our mechanical parts. We've got our WIDI module. So we're going to be using a BLM 215, I believe it is, Bluetooth module. And if you buy this sort of from us as an assembled board, it'll come pre-programmed with the WIDI firmware from CME. Otherwise, if you do this as your own project, then you'll have to sort that out. We don't. Oh, pardon me. We're not in the business of distributing anyone else's firmware, so you'll sort of have to, work that out. But I think we'll probably sell like pre-programmed modules or something as part of the kit, if you would like to. So got to work that out exactly. Got to chat with CME more finally once we get the project out. But yeah, then we've got this connector here. These two don't have 3D models yet. I've just been a little bit lazy with that, unfortunately. But we're going to save that. Some power stuff down here, power filtering and input, and you see we've got these mirrored stages because we're using the same sort of components and topology for whether we want to draw our power from the main board at like the 9-volt input or through the 5-volt supply on this ribbon connector here. So let's go back to our project file here, and we're going to update our 3D models to the latest versions. All right, there we go. You'll see we've got this little daughter board here that kind of squeezes around some of the components. And this mounts our connectors, so our 3.5mm jacks, the USB-C there for data. Won't be powered by USB-C. But yeah, it's looking pretty good. Our analog to digital converter, the sort of venerable, what's an MC3008, I believe. Let's go back to it here. Oh, sorry, that's our TRS breakout board. MCP3008, yeah. So, yeah, welcome if you're just tuning in. If you are joining us, then leave a comment in the chat, say hi. I'll be monitoring the chat the whole time. Hey, Wizard at Play, how you doing, mate? I don't think I've seen you in the stream here before. I could be wrong. I have notoriously terrible memory for things like that, but welcome. Yeah, leave a comment, say hi. If you're working on a project yourself, then let me know. We shouted out the Gerbeltron MIDI controller bypass looper from Dan the other week. Fantastic project, and he sent a link to the chat for his GitHub repo if you wanted to build one yourself. This is a very open source oriented stream. So yeah, welcome to do that. Don't spam, of course, though, or you will get blocked if you're just spamming stuff. But yeah, and if you have any questions or comments along the way, if you'd like to ask any question about PCB layout or routing, whatever it is, then please leave that in the chat and we'll get there. So I'm just going to save that now that we've updated those models. You can see everything's fitting into our our design. Now, one thing I haven't taken into account is that this part of the PCB there is actually blocking that LED. So we're going to have to, I might just go in and nip that in the bud now. I'm going to make a couple of changes to this PCB just while we're there. I'm going to round that corner out a bit so there's less risk of it sort of hitting that switch. Then I might just add, some of the little fillets in there to make the milling of the PCB a bit easier, and then also room for that cutout. All right, so that's here. So what we're going to do is just pull this back. Let's go 1, 2, 3, 4 on our 0.5mm grid. So we're going to take that 2mm back. We'll probably take it 3mm actually, just to be nice and safe. Cool. Then what we're going to do is just add. We'll keep those as right angles. Just add some fillets here to allow for a 2mm routing bit to get in there. So I'm just adding a 1mm radius fillet on those inside corners, because imagine a curved routing bit can't actually do like that internal 90-degree corner. So all right, we're just going to save that, push that to our 3D model. So this board's going to be quite easy to route. It's not going to be much of a big deal at all. We've just got our MIDI input optocoupler, the current limiting resistors for our current loop for the MIDI out, and then some ESD protection and the mode resistors on the USB-C connector. All right, just wait for that to render. Lovely. Save that. I'm just in the habit of we save that and now it's going to update. Probably didn't need to close that, but it's a good habit to get into before you push a 3D model or something like that. Just give it a save. Very much just best practice. Okay, that's looking better. I'd still love to have some more clearance around there, but with that hole there, there's probably not too much we can do, unfortunately. Yeah, we'll revisit that. But, for now, cool. Plenty of clearance around there. I forgot to put a fillet on there, but it doesn't really matter too much, I think. Lovely. So that's looking pretty good. So this week's stream is going to be all about PCB routing. So we're going to be routing out this board. Spent a lot of time on the placement, and for good reason. We want to really carefully consider our placement to make sure that we're making things as easy as possible for ourselves. And so, yeah, you notice we've hidden a couple of these air wires, so in particular the 3.3 volts and the ground air wires, so they're not cluttering things up. Now, I've been sort of umming and ahhing about whether we do a 2-layer or a 4-layer board. From an EMC and performance perspective, a 4-layer board is going to be better. The question you have to ask yourself is it actually needed? Do I need to go to that 4-layer board? And originally I thought before I kind of realized we could expand this down here and make some room, I thought, yeah, we're going to have to do 4-layer just because of the routing density. Now I'm not so sure. We're going to treat it like I'm routing a 2-layer board, and that's good practice where unless you've got, like impedance critical, impedance controlled wires that you have to have, if you're doing that sort of stuff, then you probably know all about this, but, in particular high-speed USB or any other high-speed differential signaling, then yeah, a 2-layer board's probably not going to cut it. But we're only using USB like full speed, so 12 megabits a second, and those edge rates are still pretty out there, but it's nowhere near as fast as 480 megabits a second. So it's good practice when you're doing a surface mounted board. Treat it like, just when you're routing everyday signals, low voltage, low current, kind of non-sensitive analog signals, and, just your bread and butter stuff. Treat it like a 1-layer board. So try and route as much, and in your placement, place it as carefully as possible and route as much so that you can do as much on the same layer as your components. So that way, for a 2-layer board, generally your bottom layer is going to be a solid ground plane. And that way it's going to be as intact as possible. And you're also making the most of your routing efficiency and placement. So only thing we have left to do, I believe, is we need to actually put some signals on this connector. We sort of just left that bare. And what we're going to do is take a look at this connector here and where we'll play around with those resistors first, but I just want to name this connector so we can route out the main board. What makes the most sense for this board, because it's a little more constrained, and then we can sort of take a look at everything else. So, if we're looking here, I'm just going to move a couple of these out of the way. I'm not actually going to do any sort of, fine-tuned placement. Well, that's going to be a bit tricky. We might have to, as our 3D model, we might have to move that forward a bit. Yeah. Okay. Well, what we will do while we're here is just go back to our metric grid. Get rid of that fillet. I'm going to add another 1.5 mil there, so we can kind of bring that away from the USB-C connector there. But then we're going to fillet this. Oh, sorry. What's my fillet tool? So a 4mm fillet on there, which is going to help keep it away from that foot switch there. All right. So, we're just going to drag some of these into at least roughly where they need to be. That's MIDI, that's the USB CC. Just going to ignore violators for the moment. What have we got? 5K1, that's for the MIDI. 39K, so that's for our V-bus sensing. That can probably go there, about there. Oh, we need this this needs to be as close as possible, so it's probably, probably going to put that there somewhere. So, we're just really loosely putting some components where they need to be so we can look at what makes the most sense for where to route these signals out. So, that's going to go there. The exact order of these doesn't really matter. Somewhere there, let's say. Cool. Close enough. So what I'm seeing is we're going to have our USB lines coming out from here. Now, in an ideal world, I would like to run those on this top layer here. Whether or not we can do that, I'm not entirely sure with our space. We should be able to and run them there. So it's going to make sense for our USB to be on pins 7 and 8, right? Which is that kind of part of the connector closest to the USB-C. So if we look at our 3D model, that is on that side. Let me get it more. Hang on. Try and get them aligned. They're not perfectly aligned. I'll move them around a bit, but it's on that side. So whatever, going back to our main board, the pins on that side. Okay, so it's kind of flipped. So what is 7 and 8 on here is going to be 1 and 2 on the other board. So probably going to run positive to 7 and our negative in the differential pair to 8. I would suggest. So go here. We are going to come in here. All right. So that's going to be, what did I say? USB N. What do I call them? DUSB. DUSB N. Pretty sure that's that one there. Yep. And DUSB P. And that one there. Hello, if you're just tuning in, welcome. We're just checking where our signals are going to go. So that's those taken care of. Next up, it probably makes sense to put, like ground, maybe to just kind of help shield the our USB as well. I think makes a bit of sense. Not that it's particularly fast, but there's still those edge rates can contain a bit of energy. So connect that one there to ground. Lovely. Then we might as well put our power next. So 3.3 volts, and then our VBus sense, I think, will be good. And we don't have to run actual power from the USB connector because this is not going to be bus powered at all. So what do we say? We'll go plus 3V3. Yep. And then VBus sense. There. All right, we'll pull all of these out a bit, just so they can be nice and aligned. VBus sense. Now, what else do we have left? Well, I believe we need our MIDI, TX, and RX. And that should be it. Were we exposing VBus? I'm not entirely sure. I mean, we can probably route it. We've got enough pins anyway that we might as well. And then we just need TX and RX. So, I'd say we'll probably route it just in case, but I don't think we're going to use it on the other end. Better to have it there if we decide, we might want to power because I can actually see that we might want to power our main logic maybe, but look, I'm really not sure whether we need to. Then TX and RX. So that's our TX there. So it probably makes sense to put TX first and then RX, I'd say. Yeah, and then that way we should be able to pretty much write everything on a single layer. So TX, MIDI, and RX, MIDI. Gonna go there. Cool. Cool. All right. Now that gives us layout. I'm actually just going to. All right. Now we're going to pretty much reverse that. So we'll go to where our connectors are here. Okay. So on 1, we want, because we're basically just inverting it. So 1 is going to be DUSB-N. I am just going to rotate this. It's technically like an incoming connector, so we'll put it on the left, signals going from left to right and all that jazz. Yeah, sort of, but not really. We'll chuck these out there a bit. We do not have VBus sense there. I'm just going to copy this ground. to there. Then we had 3.3 volts, remove those. Cool. What do we have next? We had V-Bus Sense and then V-Bus, I believe. So we'll call that V-Bus Sense and V-Bus. I've kind of got it there. It's going to flag an ERC error for unconnected stuff anyway. But oh well, we'll just leave it there. We can always just not use it. Cool. All right, just bring these in a little bit. Great. So now we have that that connection. I'm going to run an error rules check, electronic rules check. I'm just going to check some of these errors. So this is, you can't see this window, unfortunately, but what I'm doing is it's just going through and highlighting any errors. And a lot of these are just, output and supply pins mixed. And they're just because maybe when I've created this voltage regulator symbol, I haven't set the direction or the type of the pin properly. But, I know that visually looking at it, that's fine. And I pretty much know that all of these output and supply pin mixed errors aren't, really errors. But these are the important ones. So only one pin on net LED L in. That's important. So what that's saying is we've got some net LED L in that isn't connected to anything else. Now, what we're doing here is we're running these into our ADC with a current limiting resistor. And the intention is that these should be connected to this schematic's still a bit of a hot mess. I really need to go through and clean it up here. And so I've obviously LED L and LED R. Right, so I've just misnamed them there, really. So I'm going to go back here and get rid of the in. I believe it's LED underscore L. Yep. And then LED underscore R. Okay. Now we'll go back to our error rules check. Only one pin on LED anode. Interesting. What have I meant by LED? Oh, I bet that's meant to be LED R. But I can't see LED. I'm just trying to work out what I've done. I've kind of, oh no, LED R, LED anode. Okay, yeah. So that's basically just going to be separate power for the LEDs there. Now I'm trying to work out if we really need that. I don't think so. We are probably just going to kind of leave that unconnected. We don't need that LED power there. And then one pin on toggle. Yeah, and that's by design because we don't actually need those pins. I'm going to pin on a V bus. Yep. And then IC3 has these uninvoked gates, which we know about because we're only using half this quad op amp. And we're not using a dual op amp because we're already using this quad op amp in other places. So we might as well just use the same chip because that if we, have the more unique parts you have, the more that's going to increase the cost and the complexity of your manufacturing when you're running it through your pick and place and you're having to assign your reels and feeders. So that's looking pretty good. All of the, I'm going to leave those there. I'm going to approve these ones. I'm going to leave these there. S has no value. That doesn't really matter. I'm going to leave those there because I want them there as a reminder that I've got those unconnected nets, but I'm okay with those. And that's just I like to leave those there as a reminder if, I might want to come back to them or not. I know some people have to have all those errors cleared. I like to be a little more, picky and choosy with how I manage those. This really needs cleaning up here. I have really bad practice when it comes to, schematic cleanliness, I guess you'd call it. Like this isn't too bad, but this is a bit how you going. So kind of Like these should probably be flipped around, I'd say. So just to clean this up, I know we said we're doing PCB routing. Sorry, I just want to try and clean this mess up a bit while I'm here. It's not going to be the neatest thing in the world, but honestly, I'm not super diligent with that anyway sometimes. So just going to save that now. I think everything's looking pretty good. So we've got, got all our signals routed here. Now this, we have shot ourselves in the foot a bit here. And this is really not ideal because now our USB pins are at the very bottom of there, and they are the most important ones. So we sort of have a decision to make because of the way we've laid out our kind of our boards. We've said that, okay, well, we're going to run our ribbon cable like that. We either have really bad USB routing on this board, or we have really bad USB routing on that board, and we have to kind of pick and choose which one. I guess like the only other option is that, let me get those foot switches out of the way, is that we do something like the ribbon cable goes like that, and then to there. Not a fan of that for, I guess, a couple of reasons, but it's not the end of the world, actually. We've got lots of room. The more I think about it, the more we might have to do that. Like we could just move that. Move that to there. They are also out of alignment because I changed the location of that, but they're going to be a bit out of alignment because I'm going to fiddle around with the placement of that anyway. So I'm not too critically concerned with that, but I'll probably just bring this up a bit. If we brought that in and flipped it around, we do get much nicer routing. Let's save that. I'm going to take a look at the 3D model for this because then we can just run our pardon me, run our USB traces up along there. And as we're doing the routing, we are going to play around with the component placement a little bit. And yeah, see sort of how everything's going. It's just the reality of it. So that cable's going to come in, cable entry is going to be there. So we'll see how much room, like the general on one of these cables, you can get a fair, a decent bend. You obviously don't want to be putting too much strain on them. And I'm not sure whether that's going to be like too much kind of flex. I wouldn't really want it to compress or flex more than what I've got at the moment. Where are my calipers? Might take I'm just going to grab some calipers and actually measure that. I mean, I can eyeball that. That's fine. It's probably at that point, 6-7 mil maybe, which I'm pretty sure is going to be more than that clearance. So I don't really love that. From there to there is 4.4. That is definitely on the dicier side of things. You're going to be squishing that ribbon cable right down there. In order for that to sort of work, it's probably not going to be the end of the world, if I'm honest. You'd sort of do something like that with the original ribbon connector, and it's not going to interfere with anything. You'll still be able to use that original ribbon connector. Yeah, look, I think we're going to do that. I think that's how it's going to connect. And there's room for it to sort of loop up there. How much? I'm going to check our clearance from like that plane to there. What's that? 2 mil. That is what might be getting a bit dicey. We may need to move that closer in, I think. All right. Which is weird. I thought we did. Why is it? Oh, I haven't. Hang on. Have I? Yeah, silly. I've been looking at all of this and I haven't even updated the 3D model. Ugh. Rookie. Okay, there we go. That's a lot better. That's going to be a pretty adequate amount of clearance, I would think. Yeah, 6 mil. That's going to be fine. So it's kind of going to go up and down and then there. Not the prettiest thing, but I think that's actually going to be a pretty reasonable outcome. Lovely. So now, without further ado, wait, where's the right board? Let's crack into it. So I'm going to, when we're doing PCB routing, we want to start with the most critical things first. It can be really tempting to just dive in and say, oh, look at this, little simple analog circuit. We'll connect all that up and away we go. But what we want to do is start with the critical sections first. And that's basically your power and any high-speed signals are going to be there. And you might think, well, power is just, it's just DC. What could go wrong with that? But what you want to do is consider your power at every stage of the routing, because if you don't have good reference planes for any high-speed signals, or just really nice low impedance traces for all of your power, then you can really start running into issues. Kamagutsa, as Dave Jones would say. So I'm going to route these USB signals, our decoupling, and this crystal first, because they're along with this flash, they're probably the three most critical pieces of trace infrastructure that we have. So this is where, pardon me, this is where I switch to our imperial grid, and I go to 6.25 mil. So mil being thousandths of an inch, or 6.25 thou. Some general rules of thumb here. Don't use the thinnest trace that your PCB manufacturer says they can do. So if we go to the JLC website, JLC PCB trace width, it's going to give us some information now on their sort of basic. Where are we? We want trace width, minimum trace width and spacing. So 1 to 2 layers, they can do 5 mil. On a 4-layer board, they can do 3.5 mil. Do not, unless you absolutely can avoid it, do not use that minimum trace width unless you absolutely have to, because that's basically the borderline of what they can do. And if you want reliability, want all your boards to come out and just work, and don't want any manufacturing issues or delays, don't push that. And there's very few things in this sphere of design where we're looking at analog signals, some fairly lower speed digital, like our RP2040 is clocked at 133 megahertz compared to some of the multiple gigahertz processors that we know and love nowadays. It's pretty slow. So we don't need to be pushing that envelope. So I like to use 8 mil for as much as I can. And I'm not going to be too pedantic about these USB lines. Like I said, it is only USB full speed. So if you're doing this properly, you'd probably use 6 mil or 6 thou traces to reduce the capacitance. But I'm not going to. I'm going to use 8 thou because I know it's going to work just fine. It's not going to be a problem, and it's just going to ensure extra reliability. And then it's only if I'm really in a squeeze, and I might switch to a 6 thou trace just to get past maybe a tight bottleneck, and then I'll go back to 8 thou whenever possible. So if you're routing differential pairs, we can click on this route differential pair button, and it knows, because we've appended these signals with _n and _p, it knows that they are the positive and negative differential pair signals. So just going to take advantage of this, and we're kind of going to route them up to there. And again, I'm using this just to sort of get to here, not actually going to follow the differential pair routing all the way through. It's just a lazy man's way of doing that. And I'm going to separate these a little bit, even though we shouldn't, because that's going to introduce a greater degree of length mismatch. Because again, it's USB full speed. It really does not matter that much. You can kind of route USB full speed. Don't take this too literally, but you can almost route it however you want, and it's probably going to work as long as you adhere to decent design for your power and ground and things like that. So that's what we're doing. It's not the best. It's not the worst. It's going to do a job for us. Now we're going to route, carefully kind of hand route these. And I don't use an auto router for anything. I think that auto routers generally, you spend more time in the cleanup of auto routing jobs and verification than you actually save by just routing it by hand, honestly. I typically will just say, don't bother. I'm just going to kind of put those traces so that they line up with each other somewhat. We'll straighten out any little things. Cool. That's, that's going to be just fine, even though they're not perfectly length matched or anything. All right. Now, next up is going to be this crystal. Okay. Now, there's a couple of things we want to consider, and this is both with our crystal, our USB signals, anything that's high speed and timing critical. Don't run traces underneath it. Ideally, you just have these traces and you have just your reference, nothing else. You don't want to be having stuff in. We're going to kind of make a bounding box for this section of the schematic, and nothing else is going to come into it, okay? Except crystal signal goes in, crystal signal comes out. That's the idea. And if you follow that mantra where it's just, that's its sole purpose, and you keep critical traces away. Again, I'm going to be using 8th thou traces because there's no need to use 6th thou here. It's not that high speed that we need to kind of worry about that. And we've got these extra load capacitors here to and we've allowed for some general rule of thumb parasitic capacitance in our design. So that's not going to be a problem. We're going to route this down. I want to avoid that ground if possible. But you also want to try and avoid, see here, if we route that, you've got this acute angle. It's not so much of an issue anymore, but you still want to avoid it. 2 reasons. One, the acid that is going to eat away the various layers as they build this PCB. This can be a bit of a trap for leftover acid. It can kind of get little pockets that remain in there and continue eating away, and it can degrade the quality of your traces. 2, you want to avoid, basically, you'll very rarely see me do 90-degree. Morning, Brad. How you doing? Sorry. Morning, Dan. I was too busy reading your last name. How you doing, mate? You'll very rarely see me do 90-degree bends in traces, if at all. I might do T-junctions for things like power or, really low-speed stuff. But ideally, you're doing 45-degree bends on everything, because those sharp corners can introduce discontinuities and cause all kinds of issues with like impedance changes, and then you get nasty stuff. You want to avoid it. So we're not going to be doing that. What we're going to do instead is route it down to here, and we'll probably come into the corner there so we avoid any of those sharp edges. All right. So obviously you're going to get these 90-degree things here. Pardon me. Here. And if you were being, honestly, if you were being balls to the wall pedantic about this, you'd put a very slight sort of kind of chamfer or fillet on there, but that's not important. Just avoid it where possible, and it will make your life a lot easier. Okay, then we've got this ground there. I'm going to leave our ground because, like I said, I haven't decided whether we're going to do a 2 or a 4-layer board, and that will inform some of the decision about how I route, whether we just drop these straight down or we try and interconnect them a little bit. So along with this crystal here, we have this load capacitor, which we've connected like so. Beautiful. Beautiful. Now that's some decoupling for the input. They're the 2 main things taken care of. What are we going to route next? Well, let's take a look at what other high-speed signals we might have. I'm not sold on those current limiting resistors being there, by the way. I'm thinking maybe they might slot in there, but I want to keep the routing space for routing there. Well, what next? Now, what I like to do typically is to go ahead and just route out the majority of the non-critical signals, the we can just get rid of a lot of these air wires and start kind of, taking care of business, so to speak. Just double checking where because on these potentiometers, I'm realizing I might actually have to move these from under there, because as I'm looking at it, I realize we can't do this because there's these sort of support tabs that are on the bottom of the pot. Anyone watching this last week was probably, yelling, just being like, "You idiot, what are you doing?" So sorry to anyone who that happened. There's going to be, I don't want to take any chances. So a bit disruptive, but quickly, we're going to move all of these out and away from there. That's probably okay. I think I'll keep the decoupling capacitors where they are, and because there's going to be enough room on top for one of those, and then we're going to move this filtering out of the way from underneath. So I'm just looking at a potentiometer there, so I can get a gauge for it. All right, well, we'll put our inline resistor there. Just sort of snap that like such. That'll be nice and neat and do a job for us. Oh, it's going to be the same distance underneath. I can put those underneath, can't I? I'm thinking, and I might actually, I'm wondering whether, no, it's probably not worth flipping that around. It might actually be worth us rotating these resistors here, because see how we've got kind of data coming in on the opposite side, then data going out on that side. Whereas if we rotate these around, no, not the pot, not you. This is where it's really, really frustrating. And there's got to be an easy way to do this. If you know of the best way to do this, please tell me, to sort of isolate, when you have two components that are sitting on top of each other. How do you get to kind of what's behind it? I'm sure that I'm missing something, but, maybe I am. I'm just going to rotate those around so it makes a bit more sense there. Cool. All right. Bring that back there. So see how, it's just cleaning up. And they're the sorts of things. Oh, I am so sorry. Showing the wrong screen. Thank you, Cacklin, for letting me know. Oh, I do that all the time. We were looking at the routing rules. I'm so sorry, guys. Okay. Well, we routed a USB here. Then we routed out, so those differential pairs I was talking about. In fact, having a look at that. Can you hear me now? What is going on? How long has the mic been gone for? Was it working before? Can you let me know if it was working before and it's only been the last short amount of time that it wasn't working, or has that been a whole stream thing? So I'm going to be really sad if it was a whole stream kind of thing. It's going to make me very sad. Anyway, that's going to be enough clearance between the little support tab on the pot there. I think. I hope. Yeah, that's gonna be fine. Probably will put those nice and close together. It's probably a little bit closer than is prudent, but they've got enough space for the pick and place. Honestly, that's fine. And we'll put those there, so they're nice and close. So we get low impedance there. It was gone for the last minute. Okay, sorry. PCB things. We're rotating the LEDs, making the routing better. That's all. I'm really sorry about some of those issues. I'm not sure why that happened. Why the mic was just decided to, take a little holiday for a minute. Now it's back, but they must not be on a. Must be on some sort of weird grid that I've got there. What did I? How do I have those? Oh, 25.2. Okay, so it needs to be. That's still 25. Yeah, cool. Okay, 25.2. So I'm pretty sure we'll be able to check because these were symmetrical. So 25.2. Yeah, lovely. How are you doing, Cacklin? What's going on? You working on any particular projects at the moment, or how's your morning going? I mean, it's morning for me here. Funnily enough, the location that you are streaming from is not the be-all and end-all. Funny about that. Okay, cool. So I've flipped those around. They're going to be still under the, directly under the pots, but now we've got... we're going to just switch these decoupling caps and get those components out of there. I forgot that these style of pots that I'm going to use have that those support legs under there. Anyway, always working on projects, work and personal. Yeah, for sure. If you've got anything that's sort of available to be shared in the public domain, by all means, let us know. I love seeing what people are working on. Pretty much, we're just going to do something like that. I think that's going to be fine. I'm not being too pedantic about this. What I actually should be doing, reconsidering this, and this is where you're routing, and I probably just boneheaded because I was trying to cluster these next to the pots. I probably should be putting this filtering close to the ADC. I really should. And if you're not sure why, think about how this filtering is working. The idea is to filter out noise. And I know it's probably not going to be a performance issue at all. But, right, we filter out, we've got a low-pass filter here localized at our potentiometer. And the idea is to get rid of, small jittery changes or tiny bounce of ripple in the power supply and just give a nice, smooth, clean analog voltage to this ADC. We clean it there. And then we run it here. And let's say it's experiencing some interference along the way, some high-speed interference. Well, it's going to pick that back up again before going into the ADC. So ideally, you're filtering as close as possible to the input here, which is what I should have been doing all along. I just kind of forgot. I'm also going to change the order of these ADC channels to kind of better match the relative positions of everything. So that's going to be somewhere about there. So I'm going to go ahead and put pot this one onto ADC. So basically what is ADC in 0 is going to be ADC in 5, because that is going to make life a whole lot simpler. Okay. Where's my pot? Here. I'm going to change that to ADC in 5. There we go. See, we're cleaning up those traces, and I don't bother doing too much of this. See you, Cacklin. Enjoy your meeting. Sounds like fun. I don't bother going too crazy on this in the schematic section. I wait till I'm doing the routing so I can get a feel for how the board's coming together. So likewise, we're going to. In fact, I'm pretty sure I know how the mic got muted. I dare say that I'm using M as a hotkey in Fusion for move, and I was over in the restream window. Yep, and M is the hotkey for mute. So there you go. Sorry about that, ladies and gentlemen. Okay, that one's probably going to go to there. That's actually, I'm going to move those LEDs down. That's going to go to 7. Those LEDs are going to go everything's going to move down one. So that is going to go to ADC in 4. That pot, which I believe is on, what's that on? That's on 4 there. Okay. So, oh no, sorry, that's ADC in 3. Yeah. ADC in 3 is going to become ADC 7. There. And these are each just going to get bumped down 1 respectively. So 5 and 6. Cool. So that's going to be much more ordered. This is what we're trying to do, is make the routing as simple as possible. And put that filtering there. Then that's going to be filtered there, which is going to be very nice. And we can just run those straight down. In fact, I'm probably going to end up putting these. I'm going to end up putting these somewhere in here, I'd say, so that I can kind of just route them down there, out of the way. So we'll finalize that in a bit. Then our pot there. Then I'd say this pot is going to go into sort of this pin here, so that we can route out this pot all the way over here. It's going to go. We don't need to worry about that copper clear there, because this isn't going to be a PCB antenna. So I'm going to route that kind of right around the border there and down. That's going to be fine. 2 ADC in 3. Yeah, lovely. And that's going to 1. Okay, so that I need to change. I say the word that and I just muse a lot, so sorry. So 2 is going to become 3, 1's going to become 2, is the kind of long and short of it. Wrong schematic. Make that 2. Make that 3. That should be exactly what we want. Lovely. Lovely, lovely. And then our last remaining, so we've got 1, 2, 3, 4, 5, 6, 7. Trying to work out. Okay. Then we only need to account for this guy here. Which get those RC filter popping away. And I'm probably just going to use that ADC 0, I think, for that. Probably makes the most sense. That's going to be channel 0 of our ADC. Fantastic, and we'll just leave ADC 1. This probably doesn't make much sense connecting it up. Cool. All right. Now, can place our. Probably will just give that a bit of breathing room. Go back to a 25 thou grid. Just give it a healthy dose of breathing room. And come down to there. It's going to be sort of spreading this filtering out a bit. That probably makes more sense to do something like this. Maybe, I don't even know. I spend so much time just messing around with placement like this. For the sake of things being nice and that's silly. We'll leave that there then. All right, probably move that, scooch that over and put our filtering there. Cool. I'm going to make sure I keep the cap on the same side, not for any particular performance reason, but just so that it's easier to make sense of the board layout. If I'm looking at things later on, we'll make sure we snap these to our grid. We'll jump back to, I don't know why I went to our 25-hour grid, to be honest. Okay. Then we've got the filtering from our pot down there, which can stay there. It's going to do a job for us. Move these over and try and maintain a bit of a pattern. So we'll space those a bit apart. Sorry about all the coughing, folks. Just one of those things where it just seems to stick around and you can't shake. Okay, cool. Well, that's looking pretty good. If I don't say so myself. Nice, and we'll keep, might just make those symmetrical, if for no other reason than it looks aesthetically pleasing, which I guess is as good a reason as anything. So that's sort of the center of this little section here. So I'm just gonna, break. Not much I can do there. Looks pretty symmetrical to me. In fact, it was probably just fine before I went and moved that. Anyway, bump those up so it looks, fairly uniform. Great. And that's about there. Cool. Everything's nice and aligned. 1, 2, 3, 4, 5. Move those in a touch just so they're nice and kind of sameness. We like that sameness. Cool. That looks pretty good. Got room to route all our traces. We've got our filtering caps in the correct positions. Everything is looking nice. So I'm going to route this ADC stuff now because I want to make this is going to be quick and easy to get to. Again, I'm just using 8th-hour traces. So the beauty is because we've just tried to spend the time making sure everything's really nicely aligned, we can just go like that. Need to remember to switch back to a 6.25-hour grid. I'm going to route that up there, keep as much space in between these signals as possible to reduce any interference. Not that we're really going to get much, but again, we're, following best practices doesn't hurt at all, even if it's not strictly necessary. Okay. Let's take a look. I'm basically just sort of picking the low-hanging fruit now, the things that I can route to get it out of the way. So for this, I'll do the power a little bit later because then I don't have to go back and forth changing PCB trace sizes. So this is our LED for the WIDI module. We can route these LED traces like so. I'm going to give it a bit more clearance away from that resistor, not because it needs it, but just because I have the space to do so. And again, where possible, just take the space. No need to turn everything into a can of sardines if you don't have to. But I've noticed that it's going to be a bit difficult to get that trace out of there. Pardon me. So although what I can do is I can always just run that kind of down there because I don't want to take that up any higher than it has to be. So yeah, they're on a weird, I think I've snapped those to the grid properly. Let's do this. So let's fix that. Cool. That's pretty good. It's kind of frustrating to have forgotten that though. We'll just check everything's our push and shove router hasn't mucked anything up. All right, that's looking pretty good, I think. Cool. then they're going to get routed kind of, I'd suggest we might have to move those test points, although we can route those down into there probably. Routing those out, I hadn't thought about the placement for those. I think because I had in my head that a 4-layer PCB would just be a certainty. And now that I'm realizing, hey, we could probably get away with just a 2-layer board, it's probably, might need to play around with that spacing. I'll leave that for now, though. All right, going to route some of this stuff with our toggle switch. So again, it's debouncing. Great. What else have we got? All right, I think it's time we do our power for the microcontroller. So this is where we're going to take a look. I'm just going to keep this design sheet open in another window, which we can take a look at if we want to, for the hardware design for RP2040, where they show some of the capacitor layout and the decoupling, which we're just going to follow, but everything should be fairly, just as to which pins are. So trick here is we're taking the opposite approach. We want our traces to be as wide as possible to reduce the inductance here. So because of these pads, we can only really use 1/8 thou traces. You see, we can't really use any wider, otherwise we're going to get, and it's going to be too close and get an error. So we're going to break these out with an 1/8 thou trace, like so, and then move to probably 16 thou trace. Gonna do a job for us. We need to make sure we've got enough room for these. So again, going to be breaking them out with our 1/8 thou traces, and then going to our 16 thou there. And I know some people sort of step up the trace size incrementally, so you don't have that big kind of blob there, and that can look nice and it can serve a purpose, but we don't really need to get that pedantic about it here. Just where possible for your power traces, it's a good idea. Use the within reason, because you don't want to cause thermal issues, but use thicker traces. Where you can manage it. A little boy in the background. All right. Cool. That one's going to go to here. So again, we're going to escape that up to there. That 1/8 thou trace, and then a big chunky boy. Where's that 3.3 going? Needing to run to. That'll be that trace there. Okay. My power's looking pretty good. I'm happy with the width. Very happy with the width I'm able to get on those signals. Sorry, on the decoupling. I'm probably going to have to do that because we need room for. This is one of the kind of core voltage regulator pins. Now, don't need to worry about our serial wire debug lines. They're low speed. They're only running at 400 kilohertz. Nothing of particular, note to worry about there. Let me bring this down a bit. See if I can squeeze some extra width out. Yeah, it's probably going to have to do. We can maybe get a bit more out of our 16 thou trace here. Oh, no, that was ambitious. No, never mind. That's good enough. Leave it as it was. Okay. And I'm just going to move that line down and out away from our power supply decoupling to give it a bit more breathing room. Okay. Lovely. What's that? LED data. Oh, okay. That's the start of our our addressable LED run. So what we're also going to need to look at is the order that our LEDs connect up in, because we want to make sure that we don't want to be zigzagging all the way across the board. So I'd say, given that the LED data's there, it's probably we've got this PWMs going there that I don't want to kind of interrupt. We'll cross that bridge when we come to it. It's again a fairly low frequency signal, so it can kind of just be done. However, mate, Daddy's working. I'm sorry. I'll come out in a little bit. Okay. Yeah, good boy. Okay. Well, next kind of most critical will be this quad spy package here. This is going to be a little bit tricky. It's a bit of a bird's nest, but we'll see how we go. So switching back to our 1/8 hour traces, you can probably get away with pretty much every PCB manufacturer can really reliably do 6 hour traces. It's just a personal thing where I like to do 1/8 hour just to be safe and make sure that I'm not going to run in. And this, if you put it this way, if you design your PCB using 1/8 hour traces for everything, everyone will be able to make your PCB. You can take it wherever you want, and you're not going to have any issues. Oh, I missed some decoupling here. So, in the current climate of supply chain shortages, it's not the worst idea to approach your design from the perspective of, I want to make this as easy as possible for anyone to manufacture, just in case I have to change manufacturers. All right, those UART lines are probably going to run down and around to there. So, I still need to do this decoupling, don't I? Pretty sure 14.8 and 49 share. I'm just following some of the compromises that they made for the in the actual Pico layout. Yeah, 48 and 49 share a capacitor in that, and things were getting a little bit tight here, so I'm not too worried about that. Now I'm going to break these out like so, rather than just connecting them across, so it makes the inspection a bit easier, but that's not the most ideal. Let's do something like that. That's better. We can probably even just take a 16th hour trace from. No, that doesn't look very nice, does it? Having that big blob. We'll kind of take that to route. It kind of gets sticky a little bit in Eagle. You can't run to just there. It doesn't like it, so you have to route your trace and then use the move, and that is a bit annoying. I love it if they fix that. No, I don't love that. Probably is what it is. I'm gonna just try and make this look a little more like that. We'll come back to that. Aesthetically, don't love it, but I'm really nitpicking on that one. That's not a performance thing at all. I just want it to look nice. Okay, take this 16 trace. I'm going to bring that up to there, because I need room for these pins on our quad spy. Speaking of, I'm going to have to rerun these so that got some room to break those out. And what we can do, switching back to our 1/8 hour trace, just going to bring it up and like that. There we go. Now, will we have room? I'm going to make that on there 1/8 hour as well. Will we have room here? We'll see. Okay, so this is an example where we are probably going to have to switch to some 6 hour traces here. Okay, they're only short, so it's not a big deal, but I'm just going to change all of these to be 6th thou, and then it can go back into 8th thou down there. So again, I'm only switching to that sort of where absolutely necessary to save that room. That there. And then we're going to change this to be 6th thou as well. So now we can break these pins out. I'm not a fan of push and shove routing, to be honest. For more complex boards, yeah, where you've already got, you want to apply like meandering rules and critical impedance kind of stuff. For this sort of thing, not a fan of it. I like to just have full control where my traces are going. And I want to get that, because that's going to be a fairly high-speed data line, just as much separation between that that power line as possible, so that we don't have any kind of disturbances being introduced. Might do something like this. You know what? I'm going to reroute that because it's not working, and I want to keep as much clearance as possible. So if we do this, then I can move that out of the way fairly substantially from that quad spy lines, and that's going to, the more physical separation you can provide between signals, the better. That's the easiest way to prevent crosstalk and other issues like that. We're going to have to stick to our 6th thou routing here. Okay, and that's going to kind of be mirrored, isn't it? All right. So once we get to here, we'll be in the clear. Okay, so we can go back to our 8th thou here. All right, then we can come down here. Again, giving that pin as much room as is possible. Yep, so we're going to have to bring that. Oh, actually, hang on, we'll bring that down. That makes a bit more sense. Okay. Not too bad. Not too bad. While I'm here, I said I was going to do power later, but we're just going to run a nice 16 thou thick boy trace. Actually, no, because I want to. The reason I'm waiting is I want to know whether I'm going to VIA drop to like a 3.3 volt reference plane or not, or power plane. So yeah. All right. Well, we've got this boot pin for our quad spy flash. Might as well route that. So this is an example where that right angle doesn't matter. This is just a very rarely used switch when you're programming it. What I am going to do while I think of it is I'm going to rotate these two LEDs as well, even though it doesn't matter too much, because I would like to make sure that they're all the same rotation if possible. It's just good practice. It's going to make inspection a lot easier. It's going to reduce, you're looking at it, you're not having to account for multiple, rotations of devices. If you're debugging something, it's just going to make life simpler. And where we can make life simpler, we will. Okay. All right. That's going to be coming up to, to here. Fantastic. We'll probably run our LED data up through there if need be. All right, leave those power pins there. They aren't too important. All right, so I blocked off those TX and RX pins from being able to just route under there. Less than ideal. If I'm going to run something with a VIA, I'd rather it be that very, very low speed, just push button signal than the UART, which this still, again, not that fast. It's like going to be running at the standard slow MIDI board rate 31250, but still rather avoid it if I can. Okay, so how that makes sense for that to go down there. This is going to need to be on the inside. Okay. Alright, so I can run to... Oh, obviously that's not going to be very kosher. This is a bit of a mess. Eagle, one big, and this is basically Eagle. If I'm talking about, the ECAD infusion, I'm talking about Eagle, has terrible, it's notoriously bad for creating like stubs and weird angles of things. It does not do a very good job of that at all. You see, I moved it a bit and then it was like, oh, you want like all these weird diagonals and stuff going on? Cool, let me help you with that. All right. A little bit close to that decoupling cap than I would like. I'm actually going to move the decoupling cap. It's causing me some headaches, and I just want it a little bit more spaced out. A little bit. Okay, and again, I'm going to have to sort of, tweak the placements. But the idea is just to get the general flow of things down, and then, you can't move a, it's easier to steer a moving ship. It's easier to steer a moving ship than a stationary one. So if we can just get some routing done and get a feel for how the board's coming together, it's going to be a lot easier to make those changes. Here we've got our switch emulation. So I know that this isn't going to interrupt any routing or anything like that. So we can go ahead, and because I've spent the time, carefully just making a nice placement, this is going to be really easy to route, and it's going to be nice and patterned, which fulfills my layout OCD. I'm going to make sure that these look roughly the same, because we are. Hang on, that resistor's rotated. Don't want that. Don't want that. There we go. It's like, alert! Something is not mirrored perfectly. Must fix. Again, that one's not either. Is this one? Oh, none of them were. Okay, there we go. Okay. So there. Cool. Lovely. And they can get... I don't know if I want to block all that off just yet. You know what? Yeah, sure. I'm going to. Might as well just lay these traces down. It's not like we're putting that much effort into them just yet. Sure. Okay, let's save that. Probably should have saved it a bit earlier, but this is coming together pretty nicely now. I'm going to route the ADC sections now. Now that kind of most of our critical sections minus power, but I've been considering the power as we go, so that's fine. They've been routed. So now, because this is going to get rid of a lot of kind of the airwire hassle, and then I can also work out where those signals have to come in and be routed to and from. So this is going to be just sort of very much connecting the dots, because it's patterned, it's repeated. And this is where you'll really see that spending the time in the placement will save us a lot of time in the routing, because everything is really sensibly connected together. It's just don't want to do that. Well, sure. Cool. All right. So if you're watching this not live, this is probably a good section to just like put on 2 times or something, because this is going to be very repetitive. The low speed analog signals, I've made sure that because I spent so much time on the placement again, I know I'm repeating myself. I've just, it's basically just kind of click and drag in the way that seems following the air wires is most natural. So yeah, I hope I've proven that it's worth taking the time. That's going to come down here. Lovely. Okay. Of course that needs to get routed down to here. I'm going to try and follow the routing as closely as I can. Although I kind of did a weird job on that other one, so I might go and fix that up. Because that I'll just do make it nice and symmetrical. There we go. It's looking nice. Cool. Okay. That needs to go. Avoid blocking that 3.3 volt line off there. Fantastic. Okay. Now it's sort of just rinse and repeat from here. No, it's a bit pedantic to, want to route things in the same, like the exact same way for these sort of repeated patterns. But it's, I feel like it's the mindset that's important more than what you're actually doing. Because if you get in that mindset of making your PCB layout clean, then you're going to take that approach into everything that you do with your PCB layout and actually come out with, a much better quality PCB layout. Don't know if anyone is going to get this reference, but if you surround yourself with goers, then you too shall go. Thanks, Tom and Eddie, just stole your phrase. Applying it to PCB layout and routing, probably not something that you ever intended, but it's happened, and there's nothing you can do about it now. So make of that what you will. Right. Okay, so a lot of those traces have sort of been done. Need to run our 5 volts. So again, I'm going to switch to like our decoupling capacitor. We're going to use some 16 thou traces here, big fat chonkers. I'm going to use a 12. In fact, yeah, no, there's no need for 16s. I'm going to use 12s in between them to reduce some of the thermal mass there, but not really a big deal. And these aren't going to be drawing much current at all. That's a pull-up. That's just a pull-up resistor there. That guy there. So there's no need to run that thicker trace to it. We want to keep our thermal mass down where possible. Do it like so. All right, back to our 12 thou. All right. Very nice. And there are PWM lines, which are going to go to our microcontroller. We need to route what I believe are the gates of those FETs. Okay. Actually, hang on. I want to just make sure I've done them from the same points. We're going to go from the resistor to there. Again, utter pedantic OCD, but make of that what you will. Cool. That's looking pretty good. It's looking quite good. I don't know if that's exactly where it's going to go. It might as well. That, reset button might as well go there, I guess. Run it down to there, and then it can go to the reset line on the microcontroller. Okay, maybe running this up to here. Fantastic. Cool, that's looking good. I'm going to give that a save. Okay, I'm sort of jumping around haphazardly a bit here. I know it's kind of the way that my mind works, so sorry. All right, we're going to do this last section of the ADC. Oh, sorry, DAC, so DAC. Goes down. All right, because we're only using half of this quad op amp here, we're only routing one side, essentially. Okay. Very nice. Then what are we doing? These with 12th hour traces. Yeah. Okay. Very nice. All right, let's take a look at our power section. So we're not going to really discuss the topology. If you want to look at why things are there, then take a look at some of the previous videos. But all right, I'm going to use some big, thick, chunky traces here to connect our these power lines here to reduce the impedance. And it's not a very high current board, so we don't need to go too crazy. But 20 thou is just going to really help reduce the impedance of all this. I'm going to make that a bit more symmetrical with the loading there. All right. And all right. And then we pretty much just sort of tack these on like so. You can see this is nice and straightforward. Again, broken record here, but because we spent the time on the layout, this is really, really quick and easy. And we considered the way that we were going to be routing the board as part of the layout as well. So, and that's just that sort of 9-volt header. If we decide we need to tap onto the DC, or we want to just set up a test bench setup for whatever reason. Ow, strange cut on my finger from something. Anyway, great. That's I'll deal with those grounds in a little bit. I am going to route the foot switch pins because, again, just low-hanging fruit, very easy to go and do those. Great. Good to get in the habit of routinely saving. So a lot of our signals are now routed. Now it's sort of some of these longer runs that we need to consider. So So. Need to run the PWM out. Oh, sorry, the DAC out. What we might do is just get started on that. I'm probably going to drop those vias to the those grounds through to the bottom layer with some vias, so we can definitely just shoot this up here. Like so. These ones, obviously, we can't really get away with that as much, but that goes. I'm just going to kind of get these signals in a bit of an ordered state. Okay, what I might do is make that. Actually, no, I'll keep that as is and run it over like this. Should be able to. Not quite. If I bump. Yeah, if I bump that up a little bit, then I can route this on that side of that hole. It's going to save me a bit of space. I'm just wanting to get all these signals here kind of ready to go, get the proverbial ducks in a row. And then, so that's going to have to come down there by the looks of things. 1, 2, 3, 4, 5. Great. So last one here. I'm going to run this on top so I can run the LED kind of out to this side of the board and keep that digital signal out of the way of these analog signals. I'll fix up the exact placement of these traces, make it a bit nicer, but I'm just going to get the signals roughly to where they need to go first. Oh, no. Thank you, Eagle. No, you don't want to select those traces for me? There we go. Okay. Cool. So I'm just doing this so that I know where stuff needs to go. I can always bump that down a little bit if I need to. Okay, so the foot switches are going to have to go up there. That's okay because they're such low importance in terms of traces. The actual placement for those isn't too bad. So I'm going to do the same approach here. I'm just going to get like the PWM signals up and start getting those to where kind of roughly where they need to go. Okay. There's going to be 5 of them all up. Coming up to... All right. Let's escape these. And again, we can clean up some of these traces if we decide they're a little bit meandering. We want to just reduce the number of bends, things like that. We can clean those up later. I know there's plenty of space there to nice and neatly route those. That PWM signal, unfortunately, is going to have to probably cross over there underneath. Not ideal to be crossing that digital PWM with these analog signals, but can't be helped, and the performance isn't too critical for these. So I'm just going to connect these up, although I do want that V in to be able to come straight down to the power section. So I'm going to move that, change our grid and move this just 100 nano cap down to there. It's going to do the decoupling down there. I think that's the best option. Oh, well, then I can't run that V in because we've got this analog signal here. Dang it. All right, I'm getting rid of that. I really want to route that power directly down there and just get a nice big fat trace. And if I'm using a big wide trace, it's going to be breaking up more of our ground plane. Doing it that way, of course. So Might need to reorder what pins are kind of connected to the the connector here, because that should be the furthest one, ideally. I do notice, so we're going to have to change these UART routing here to make a bit more room. We probably won't need to switch to a 6th hour trace, I don't think, but we'll come down here. That one's going to be pretty much impossible to reach, unfortunately. Oh, no, we can probably here. We'll squeeze these down to 6th hour just from here. And then that way we can be able to fit everything in. All right, bump that up. Okay. There we go, and then we'll be able to get that out of there. We might even be able to get that out of there with an 8th hour trace. Yeah, if we run that toggle. Oh, we're not running that. Fantastic. So we can run that. Can we run both of them? Probably not. Okay. Granddad picking up Hugo. Love that. Okay. This is getting very hairy. All right, this is all going to have to become 6th hour. All right. Try and keep a bit of clearance between those analog and digital signals. Now I'm thinking we might bump this decoupling cap back up a bit. Just move it out of the way a bit. That's probably best, I think, because then we can get a bit more separation between these traces, because I don't want the UART butting right up against our analog signals, potentially causing some interference issues. So if we get a nice bit of physical separation there, it's going to really help the performance of those analog signals, like so, all the way out of the way. Cool. And then we can push out to our 8th hour traces, but basically, yeah, like they're just going to be pulses. Very little going on in terms of signaling. Keeping these analog signals as intact as possible is going to be number one priority. Not because, again, they're typically crazy high performance, but yeah. Okay, so I want that to be back out. I want that to swap. So 4 and 0 on the connector are going on the schematic. We're going to swap. Where are we? So 4 and 0. So I'm going to make that DAC out 0. And the existing DAC out 0 is going to become DAC out 4. All right. And then we can try and break these out a bit. Get a bit of fresh air between them and everything else. Something like that. There we go. And just keep them away from those UART lines where possible. And we'll want enough room to maybe run like a bit of a ground shield trace between them. Might not be necessary, but I prefer to have that option. Get these broken out here so we can switch back to our 8th hour. Might as well just break these lines out now. Make sure that I've got enough room to move everything back to 8th hour first. Yeah, easy. So move those back there. It looks so big and chunky in comparison, but give that connector give that connector a bit of breathing room. You know, we don't want to be pushing it right up to the limit if we can avoid it. What have I done here? That's a bit of a mess. Fusion, I know you're trying to help, but just stop. Okay. Now, on 8th hour, we can go, keeping again a bit of room between the analog signals and that crystal circuitry. That's probably pretty reasonable. Okay, so we want to swap 4 and 1. Swap those. 4 and 1. We're going to swap. Fantastic. Okay, now which ones we gonna swap here? So 3. Oh, hang on. Sorry, 2 and 4 are gonna swap. So this is just the sort of thing where you can't really work out exactly what it is that you need to swap the pins until you kind of done the board. Not done the board, but you've started routing, and so there's not much point really fiddling around with it in the schematic section. You're just going to waste time, I find. Whereas now, you know, just a quick change, cool, we'll swap those pins around, and we can get a really nice optimal routing for these signals. Because again, we're trying to keep as much on that single layer as it makes sense to, so that we can keep a nice unbroken ground plane if we, you know, it ends up being able to stick to a 2-layer board. Because one, you know, it decreases cost. Everyone loves decreased cost, that's for sure. And 2, it makes you know, debugging, or it makes repairing something easier on a 2-layer board if the performance isn't critical. It has a lot of advantages if you can get away with it. All right, that can sweet. So that can just come down to there. Lovely. Love that. That's shaping up very nicely. Cool. So this is where I kind of like to just push it to a 3D PCB and actually just get a more physical sense of how the traces are coming together. And we can see them on our render, and just make sure that everything's just a bit of a sanity check that I like to do personally. Okay. Wait for it to render. Okay, cool. So, you know, some of these spacing's looking pretty good. That looks like it makes sense. That, again, a little bit butt ugly there, but we'll fix that. Cool. So a lot of our critical traces have been run. The architecture of the board in terms of how we're running things is looking really good. I'm really happy with this. This is not that far off being done. We'll probably call it there. It's approaching 2 hours for the stream. I need to go and actually get into the garage to be doing some runs through on the pick and place to get MIDI through and bridge 6s assembled. So that's quite important, I think. I'm going to go do that, and we'll pick this back up next week, where we're probably going to finish the routing, I'd say, and probably bring things together, and maybe even get it ordered, get a first draft board sent away to the fab by next week. So just going to, for completeness sake, bring the latest 3D model into the project here so we can cap it off. And yeah, I really love seeing the board in, you know, the 3D with those traces being run. It gives me a sense of completeness about the project. So we'll save that, and that's all for today. If you have any questions after the fact, if you're watching it, you know, later on, leave them on the video, and we'll get around to those and try and answer those as best we can. But that's all for today, guys. Have a good